Welcome to this video on inverting a 2 by 2 matrix. So you can find the inverse of any non-singular matrix. Okay, we're doing here a 2 by 2. This is very useful, in particular in A-level maths anyway, for finding other matrix or matrices. So how do we go about it? Oh, and we're only doing 2 by 2s in lower 6 in FP1. So if I have a matrix M, then its inverse is m to the minus 1. And these two multiplied together give me I, the identity matrix. So if M is A, B, C, D, then m to the minus 1, or the inverse of m, is 1 over the determinant of m. I said the determinant would be used in finding the inverse. Then I swap the A and D around. So that would be D here and A down the bottom. And for the B and C, I change the signs. So minus B minus C. And that will give me the determinant. Now, obviously, if the determinant is 0, we realize that those are singular matrix, because 1 divided by 0 you can't do. So therefore you can't have an inverse. So that's why they were singular. Now let's have a look with some actual numbers. So here we have matrix A, and it's 5, 2, 3, 2, and we want to find the inverse. So first we're going to find the determinant of A. So that's 5 multiplied by 2 minus 2 multiplied by 3, or 10 minus 6, which is 4. So the inverse of A is 1 over 4, and then multiplied by, now we swap A and D, so the 2 and the 5 switch, and then we change the sign of B and C. And this now is my inverse of A. I can multiply through by the quarter, so 2 over 4 is 1/2, or I'll do it in decimals here, 0.5, minus 2 over 4 is minus 0.5, minus 0.75, and 1.25 there for the 5 over 4. Okay, so I can multiply through by the quarter. In a lot of calculations, it often makes sense to leave the quarter outside, because you'll have other things to do, and then multiply by the quarter at the very end. Okay, so you can leave it like this or like this. Now, if I have two non-singular matrices, say A and B, and they are non-singular, so they have an inverse. Okay, then this rule applies. A, B to the minus 1 is the same as B to the minus 1, A to the minus 1. Okay, so let's look at maybe proving this. Now, I can prove this without actually having the matrices, just by looking at the A's and the B's. So if we let C equal this AB to the minus 1, then I can multiply both sides by AB, And obviously when I'm multiplying this by its inverse, that's just going to be I, the identity matrix. So ABC now equals 2I. So now if I multiply by the inverse of A, I get this, which is BC equals A inverse. And then if I multiply by the inverse of B, I get this. So that's C equals B to the minus 1, A to the minus 1. But C equaled AB to the minus 1 up here. So that is AB to the minus 1 equals B to the minus 1, A to the minus 1. Okay, so you can use this rule when solving problems in terms of like your A's and B's or M's, P's, Q's, whatever they call the matrix. So in this example, AB are non-singular matrices such that BAB is equal to I. This is B, find the matrix A. So first of all, let's start with the BAB. We want to get this in terms of A equals. So first of all, I will multiply by the inverse of B there. So that means that's inverse of B times I. So AB equals inverse of B, and then I want to multiply on the right. So multiply on the right. So A equals the inverse of B times the inverse of B. Now let's go ahead and find the inverse of B. So the determinant of B is 3 times 2 minus 1 times 5. So that is 1. So B to the minus 1 is 1 over 1. Now swap these around, 3 and 2, and change the sign of the other 2. So that is just 2 minus 1 minus 5, 3. So therefore A is 2 minus 1 minus 5, 3 multiplied by 2 minus 1 minus 5, 3. Okay, so let's work these out. So 2 times 2 is 4 and 5, so this is 9. 2 times minus 1 is minus 2, and minus 3 is minus 5. minus 10 and minus 15, minus 25, and 5 and 9, 14. And that is the matrix A, or the matrix A. Does that make sense? So I'll give you a couple of questions to try on this, and then that'll be it for matrices. Now, the next topic is transformations using matrices, so they will come back up then, obviously, but this is the main bit on using matrices in calculations and things. Don't forget to like if you enjoy the video, subscribe if you are yet to do so, and if you want to help me out financially, just consider hitting that join button. You can join for 1 month or more. It's totally up to you. Right, let's get into the questions. So here are 3 questions. Answers will be at the end of the video. Pause the video now. Okay, so for A, we want to find the determinant of A. So that's 8 minus 15 minus 7. So 8 to the minus 1 is 4, 2 minus 3 minus 5, and that is multiplied by 1 over minus 7. Or I can have minus 4 over 7, 3 over 7, 5 over 7, minus 2 over 7. Okay, right, let's find B. So determinant of B is minus 3 minus 8. So minus 3 plus 8 is 5. So B to the minus 1, 1 over 5, 3 minus 1, and then that's 4, and that's minus 2. Again, or you could write, say, as decimals. 3/5 is 0.6, minus 0.4, 0.8, minus 0.2. And then finally C. So this is 12 minus 20. So this is 32. So C to the minus 1 is 1 over 32. 6 and 2 switch. 5 and the 4 change signs. And I'll leave it like that for that one. Right, on to question 2. So given that ABC equals I, and we're given A and C, find B. So A, B, C equals I. We want to get B on its own, so B equals. So first I'll multiply by the inverse of A. So that'll leave me with BC equals inverse of A. Then I multiply by the inverse of C, that's to the right. So A to the minus 1 times C to the minus 1. So B equals A to the minus 1, C to the minus 1. So now I've got that, I need to find the inverse of A and the inverse of C. So the inverse of A is 0 minus 2, so that's 2. So inverse of A is 1 over 2, 0, 6, minus 2, 1. And the determinant of C is 12 minus 10. That's also 2. Is that right? 12, 10, yeah. So the inverse of C is a half, 4, 3, minus 5, minus 2. So B is equal to inverse of A times inverse of C. So the inverse of A is a half, 0 minus 2, 1, 6, multiplied by a half, 4 minus 5, 2 and 3. So it's a quarter, and then across and down. So 0 minus 4, across and down, 0 minus 6, across and down, so 4 and 12, 4 and 12, 16, don't know why my brain won't work then, so minus 5 and 18, 18 minus 5, 13. And there we have the matrix B, or the matrix B. I could multiply through by a quarter. There's no real need. But if I did, -1, -3 over 2, 4, and 13 over 4 there. Right, let's look at the final question 3. So, given that a equals that, where small a is a real constant, find the inverse a in terms of a. So, the determinant of a is 2a squared minus 6. So a to the -1 is 1 over 2a squared minus 6 multiplied by 2a and a minus 2 and minus 3. Now part B says write down two values of a for which a to the -1 does not exist. So that would be when the determinant equals 0. So 2a minus 6 equals 0. So that was part A, this is part B. 2a squared. So 2a equals 6. So 2a squared. A squared equals 3. A equals plus or minus 3. And there we have it. So that is the final part of this section, matrices. Okay, stay tuned for the next upcoming videos on transformations using matrices.